I'm going to go through this question, which is a good example asking us to explain the action of a buffer and to explain how a buffer solution can be made. Now, the question is in two parts. It's using glycolic acid, a weak acid, and ammonium glycolate, a salt of that weak acid, as an example of a buffer. Now, examiners in this type of question will use and can use a compound that you wouldn't have met before, but all you need to do is to apply these same principles in answering the question. Now, this question itself is broken down into 2 bullet points, so I'll work through the first bullet point first. The question is very much asking us to explain, using equations, and the first bullet point says how a solution containing glycolic acid and glycolate ions can act as a buffer. They also state, using this symbol for quality of written communication, that in your answer you should explain how the equilibrium system allows the buffer solution to control the pH. So in answering the question, the very first thing I want to do is to write an equation for that equilibrium system. So we have the weak acid, glycolic acid. We're given at the start of this question, in an earlier part, the formula for glycolic acid, HOCH2COOH. And when we put that into solution, it's a weak acid, and so it partially dissociates. So it's a reversible reaction. And some of it will dissociate into H+ ions and the negative glycolate ions, HOCH2COO-. So that's our equilibrium system that's referred to in this quality of written communication part. So let's put that onto the question right at the beginning. Now we can answer the first bullet point, how a solution containing glycolic acid and glycolate ions can act as a buffer. Now in your mind, you should first maybe think, what does a buffer solution do, and write it down. It's not really asking us to state the action of a buffer, but I think it's worthwhile just to highlight in your own mind what it is we're trying to explain. So a buffer solution minimizes pH changes on the addition of small amounts of an acid or base. Amounts of acid or base. So remember, it doesn't keep the pH absolutely constant. It's just minimizing changes. So to explain this, we need to break it into 2 parts. What happens when we add an acid to the buffer? How does it maintain the pH? And what happens when we add a base to the buffer? So we're going to start by thinking about what happens when we add the acid. Okay, and we can describe that. On adding an acid, and we're trying to explain this in terms of the equilibrium system at the top. So on adding an acid, the concentration of H+ would increase. And if we look at the equilibrium system, H+ ions are shown on the right-hand side. So if we increase the concentration of H+ by Le Chatelier, the equilibrium will shift to the left, and so it will remove the H+ and prevent pH from changing significantly. So on adding the acid, the concentration of H plus ions will increase. On adding acid, H plus increase. Equilibrium shifts to the left. And I'll state there that it's by reacting with the glycolate ions in this case, or the negative ions with the glycolate ions. So I'll write the formula for those, HOCH2COO minus. And we can show, because the question asked us to write an equation to describe that effect. So when we're adding acid, we're adding H plus ions, the equilibrium that we described at the top shifts to the left, removing those ions, and the way it shifts to the left is by the H plus ions reacting with the glycolate ions. And as the question asked us to describe that using equations, it's sensible to put an equation in showing that process. HOCH2 COOH. So that's the action of a buffer in maintaining the pH when we add acid to the buffer solution. So we've described the action of the buffer when we add an acid. Now we need to consider what happens when we add an alkali to the buffer solution. So on adding an alkali, all alkalis will generate OH minus ions in solution. Those ions will react with the H plus ions that are already present from the dissociation of the weak acid. So on adding an alkali, the OH minus ions react with the weak acid, which in this case is glycolic acid, and we can represent that by the equation of H plus ions plus OH minus ions reacting together to form water. So adding alkali, OH minus ions, will remove the H plus ions in the equilibrium system. So what will happen to the equilibrium system? We're removing H plus ions. So again, by Le Chatelier, the equilibrium will shift now to the right. Equilibrium shifts to the right to replace those H plus ions. And so we return to nearly the original concentration of H plus, and so we have a buffering action against adding an alkali. So that answers the first bullet point. We've described the action of a buffer, specifically talking about glycolic acid, a weak acid, and ammonium glycolate, which is the conjugate base of that acid, and how it can prevent the significant changes of pH when we've added an acid or an alkali. Now let's answer the second bullet point. How can this buffer be prepared from a mixture of ammonia, NH3, and glycolic acid? So the first thing to consider is what happens when we mix and react together ammonia and glycolic acid. Now, earlier in the question, we were given the formula for glycolic acid. So it's HOCH2 COOH We're putting that into solution and we're reacting it with ammonia, NH3. Now, ammonia acts as a base, and the glycolic acid is a weak acid. So the weak acid donates a proton, and that proton is accepted by the ammonia. So we form an ammonium salt, ammonium glycolate, which will have the formula NH4. We could write that down as two separate ions. They're in solutions. We've got the ammonium ion, NH4, plus the glycolate ion, which is HO, CH2, COO minus. So reacting the two together will form the ammonium salt, ammonium glycolate. Now, how are we going to produce a buffer using that reaction? You should recall that the buffer requires a mixture of a weak acid and the conjugate base of that acid, or the conjugate base being a salt of that weak acid. So in this case, a buffer solution can be formed, can be prepared, and what we need to say is that it will be by reacting. Now, there's a key word here, it's by reacting an excess of glycolic acid with ammonia. Because we've added an excess of glycolic acid, we will produce a mixture of the weak acid, glycolic acid, because we added excess, we still have some remaining, with its conjugate base. Which in this case is ammonium glycolate. So by adding a base to a weak acid and providing the acid is in excess, we can generate a mixture that will act as a buffer.